Welcome back. Today we will talk about the instrumentation signals and specifically 4 to 20 milliamps. If you have in the field, you have a device which measures pressure or temperature, how you will transfer the signal from that transmitter back to the control room. If you imagine you have a power supply, let's say 24 volt, and then you have a transmitter at the field, you run two wires to the field to this transmitter. The transmitter somehow can read or can see the pressure and then it changes its own internal resistance. So it is acting as it's a variable resistance between something to something. So it controls the flow of current in the wire. So if assume that at 0 bar pressure, your transmitter will maintain 4 milliamps. And then when the pressure goes to 10 bars, it will control the current and increase it to 20 milliamps. So the first thing is that our transmitter is a variable resistance. The second issue here is the current measured in any place of those two wires is exactly the same. In this scenario, as you can see, we have two wires from our power supply to our transmitter. And the same two wires, we send the power to the transmitter and we receive the signal back from the transmitter. That's why we call it two-wire system and we call it loop powered because there is no external power now. It's only one power supply and it is powering our loop. If you can imagine a pressure gauge, your pointer is sliding on a potentiometer and changing the resistance. So now the resistance will change with the pressure. If we have a pressure transmitter or a temperature transmitter, regardless of your measuring variable or measured variable, and regardless of your low limit and high limit or low range and high range, our transmitter will keep our current between 4 and 20 milliamps. So in the control room, always you receive 4 to 20 milliamps as our signal, and it is related linearly with our signal. So our signal measured at the control room, which is 4 to 20 milliamps, will be linear proportional to our measured variable, temperature, pressure, level, or flow or anything else, and regardless of your low range and high range. So your transmitter will be calibrated to give you 4 milliamps at the lower range and will give you 20 milliamps at the maximum of your range. How the PLC will read the current in the loop. So in this loop, as you can see, we have a transmitter, we have a wire, and we have a I/O card, or we have a resistance in our I/O card. If you have a barrier, intrinsic receive barrier, or you have a field local indicator, then probably you have other devices on the same loop. The total resistance of the system is the sum of all components on this loop: transmitter, card, and a wire. So if you look at 24 volt and you assume that you need 4 milliamps, that means your resistance, total resistance would be 6k ohms. If you want 20 milliamps to run through your wire, then the resistance would be 1.2k ohms. Card inlet resistance or input resistance. In Allen Bradley cards, Honeywell, Delta V, Emerson, Automation Direct, you will find a standard 250 ohm. In Siemens, you will find 25 ohms. Now we go into our wire. Our wire, selected wire, is 22 AWG. The resistance is 0.1 ohm per meter. If you have a cable of 200 meters between the transmitter and your PLC, that means it's a 400-meter wire, the total resistance is 42 ohm. So if your PLC input resistance is 250. If you have a local indicator of 250, that means your resistance, total resistance is 542 ohms. This is the 3051 pressure transmitter from Rosemount. They will give you a graph. You go with your supply pressure and you can see what is my maximum resistance. So what they said that your total resistance should not exceed 875 ohm. In the transmitter manual, they told us the maximum resistance in the loop and the minimum resistance in the loop. The minimum resistance to satisfy the communication, the digital communication. So if you have a hard communication, then you need at least a resistance of 250 ohms in your circuit. If you are not running a hard system, then it doesn't matter. Other vendor may express it differently. ABB, what they said is, see your supply pressure, subtract the minimum operating voltage, which is 15.3, divided by 22.5, and that would be your total maximum resistance in the loop. So here you can see the maximum is 386 ohm. In the transmitter, you can see what they do. This is very old technique, but it still can explain what is going on. They receive the 420 milliamps to do a couple of things. So the 4 milliamps is the minimum which our system will use to power its internal circuit. In fact, this is not totally true. The reason is some of those transmitters can go below up to 3.5 or 3.6 and go up to 22.5 milliamps. Why? If you look at a temperature transmitter with a thermocouple, if the thermocouple burned, then the transmitter would drive the output to 3.6 or to 22.5 based on your configuration. Again, some of the transmitter can be configured to go below 4 or more than 20 if there is internal error in the transmitter. To be able to capture this feature, your card in your PLC or your card in your DCS should be able to read outside the 4 and 20 milliamps. Be careful because most of the cards in the PLC, they will tell you 4 to 20 milliamps. They can recognize one thing only. They can recognize if the wire is cut, but they will not recognize if your transmitter is sending 3.5 milliamps or 21 or 22 milliamps. You can see they showed us here a power supply. This is my card, and they showed us your wire transmitter, 2-wire transmitter, and a power supply, and the channel, the 2 terminal of the channel. Channel 1, and then channel 2, and then the common, which is 5. So I'm expecting that there is a resistance between this terminal and the common. If you look at a different card like Siemens, they connect the terminal directly to your transmitter. Where is our power supply? And the power supply is connected to the card. At the bottom of the card, it receives the 24 volt. Internally, it provides the power to our transmitter. Some of the transmitter, they need more power. If you have a mag flow meter, if you have a transmitter with a push button and a screen and a lot of facility, this power is not enough. So it needs a separate power supply to power our transmitter. The extra power transmitter could be AC or DC, could be 110, 220, 24 volt, 48 volt DC. It depends on your transmitter and on your design. What power supply you can use. Now, if you use AC, it's much easier because you have circuit breaker in your cabinet and that's it. You send it to the transmitter. DC, you will have to send a power supply, two wires to your transmitter. You have to take care of the voltage drop through the wire, and you have to include the budget of this transmitter in your power supply. So your power supply, 24 volts, should be able to run everything plus your transmitter. The good thing about the DC that you can run the power supply and in the same cable which run the signals. The AC, you cannot run it on the same cable. It has to be in a different cable to your transmitter. It has to be on a different even cable tray. So there is a pros and cons in each type of power supply you can use. The difference between two-wire transmitter and four-wire transmitter is we have two wire for the signal in two-wire transmitter, and it also has the power. In four-wire transmitter, we have two wire for the signal, two wire for the power. How you connect the four wire? This is our standard two-wire transmitter. Power supply, transmitter, and resistance. The ADC will read the voltage drop across the resistance. The four-wire transmitter, some of them actually can power your loop. So you can't use, again, you cannot use the power supply from your PLC. What you do is you connect it directly to your resistance, and your ADC will read the voltage across this resistance. So this is our first scenario. The second scenario, that the transmitter will allow you to use your power supply from your panel, and in this case it's exactly the same as the standard two-wire transmitter. This is a Delta V card, and they will show you where to connect it. You connect, this is your two-wire transmitter. You can see the power and the signal. You got the 24 volt, goes to your transmitter. The signal comes back and goes to your resistance to the ground. If you use four-wire transmitter, and it's powered by the transmitter, the loop, you have the two wires goes to the signal, and you connect the grounds together. That means you have this resistance in your signal. Again, Prof. Das Alan Bradley, you can see the wire, two-wire transmitter and the four-wire transmitter. You can see how they connected. Here you have the power supply inside your cabinet. Here you have the power supply to your transmitter, and again, the resistance is between your terminal and the ground in both cases. Automation Direct, they give us three types of transmitter. The two-wire transmitter, the three-wire. The three-wire is exactly a four-wire, but it received 24 volts. So you, from your PLC cabinet, you send the 24 volt as your power supply to your transmitter, and then you receive the signal back, and the ground is coming for the both of them, the power and for the signal. What happened here, if you have a power supply of 24 volt again, and you short circuit in this area, then you actually have the 250 ohm is in the way of your power. So 24 volt, if you divide it by the resistance, it gives you 96 milliamp. That means you are having 2.3 watts in this resistance. Most of those stuff, they are 0.25, so it's less than a quarter of a watt resistance. So that means if you have a short circuit, you will blow up your resistance. So what we will do is we will install a fast-acting fuse in our wiring. So if you have any short circuit in the field, your fuse will be blown before you will destroy your resistance. Now, if you go into your transmitter, read it carefully. Let's say this is a Rosemount transmitter. And here they said that your internal and external power supply can be used to power your loop. There is a switch inside your transmitter. You flip it between the external and the internal power supply. If your transmitter is powering your loop, then the transmitter will give you your maximum and minimum. So thank you, and please like and share, and see the list of all about INC playlist in the description for more videos. Thank you, and see you in the next video.